when I get to example 4, I can see that I have a negative outside here, and then brackets, and then an exponent. So I'm going to simplify and move that power of 5 in, and leave it in brackets first, just to make sure that I do this properly. So I'm going to say that this is the same as negative, bracket, a negative number multiplied a odd number of times is still negative, and then I have n to the power of 2, then to the power of 5. So I have n to the 10. Then when I apply that negative in here, the negative times the negative is now going to make it positive, n to the power of 10. When I get to example B, if I think of my BEDMAS rules, typically I would do what's inside the brackets before I'm going to deal with the exponents. So I'm going to simplify everything inside of here before I deal with this exponent of 4. So in the numerator, I'm going to say that I have 4 times 3 is going to give me 12, x to the 6, y to the 3. And on the bottom I have 6, x to the 5. And all of this is still to the power of 4. Then I can simplify. Simplify the coefficients, simplify the x's, and then simplify the y's. Well, there is only one y, so I can't simplify that. But if I take 12 divided by 6, I have 2. X to the 6 divided by x to the 5 leaves me with just a singular x, and then I still have that y to the 3. And all of this is to the power of 4. Now I'm going to apply that power of 4. I have 2 to the power of 4, x to the power of 4, and y to the power of 3 to the 4 is going to be to the 12. Or when I take 2 to the 4, it's going to give me 16, x4, and y to the 12. Now remember, like with example C, you have to be careful about whether a number is inside or outside of the brackets. Because the 16 is outside of the brackets, this exponent of 2 doesn't apply to it. But in the denominator, the 2 is inside the brackets, so the exponent of 3 does apply to it. So, in the numerator, I have 16, and then x to the 3 to the 2 is x to the 6, y to the 5 to the 2 is y to the 10. In the denominator, I'm going to apply that power of 3 to the 2, so 2 to the power of 3 is going to give me 8, and I have x to the 2 to the 3, or x to the 6. And now I can simplify these. Simplify the coefficients, simplify the x's, and simplify the y's. Well, 16 divided by 8 is 2. X to the 6 and x to the 6 actually fully cancel each other out. And then I just have y to the 10. For example D, I have 5ab to the 6 all to the power of 2. So that's going to apply to the 5, to the a, and to the b to the 6. And then I just am multiplying whatever the product of that is by 4a squared b. So I'm just going to simplify the left side first. I'm going to say this is equal to 5 squared is 25. I have an a to the 2 now, and b to the 6 to the 2 is b to the 12. And I'm multiplying that by 4a squared b. I need to multiply the coefficients, multiply the a's, and multiply the b's. So 25 times 4 is 100. A to the 2, a to the 2 is a to the 4, and b to the 12 and b to the 1 is b to the 13. When it says write it in simplest form, it's asking us to do the same process that we are already doing. If I have bracket negative a, then to the power of 6, divided by bracket negative a, then to the power of 4, then this is the same as negative a to the 6 over negative a to the 4. The negative to the power of 6 is going to be positive, so I have just a to the 6, and the negative a to the power of 4 is going to be positive, and a to the 4. And then a to the 6 divided by a to the 4 leaves me with a to the 2. For example B, I don't have brackets around the negative a to the 6 here, so the power of 6 does not apply to this first negative. So I have negative a to the 6 divided by bracket negative a to the 4. And in the denominator, that power of 4 does apply to the negative. So this would be the same as negative a6 over, now it's going to be positive a to the power of 4. And I can only combine the a's, so it's going to be negative of a squared. For example C, I have negative a to the 7 divided by bracket negative a to the power of 3. In the denominator, that negative 3 times is still going to be negative, so it's actually going to be negative a to the power of 3. And I can see that I have a negative on the top and negative on the bottom, so the negative cancels out. And then a to the 7 divided by a to the 3 gives me a to the 4. For example 6, we're just combining all of this together. So I have to be careful about what is showing me and what order I have to do them in. I can't simplify inside the brackets, so then I go to the exponents. In this case, the exponent outside the bracket. I have that power of 3 that needs to apply to all of this one before I can combine them. So a negative 3 times is still negative. 2 to the power of 3 is 8. A to the 2 to the 3 is a to the 6. B to the 3 to the 3 is b to the 9. And then I have 4, a to the 5, b to the 7. If I have negative 8 times 4, that gives me negative 32. A to the 6 to the 5 is a to the 11. And b to the 9 to the 7 is b to the 16. And there's my answer. For example B, I need to apply these exponents, so I'm going to take the power of 4 here and apply it to the negative and to the z's. And I'm going to take the power of 3 on the bottom and apply it to the 2's and to the x and to the y. So what do I actually have? This is the same as 72, x4, y10. The negative to the power of 4 is just going to be positive, and I have z to the 8 now. On the bottom, I have 6 times 2 to the power of 3 is 8. X to the power of 3 now, y to the power of 6, z to the 8, and y to the 3. I'm going to have to simplify the denominator for a second step. So the numerator stays the same, 72x4, y10, z8. On the bottom, I have the 6 times the 8 is going to give me 48. I have x to the 3. I have the y to the 6 and y to the 3, so I have y to the 9. And I have z to the 8. And now I can simplify the coefficient, simplify the x's, simplify the y's, and simplify the z's. So 72 does not divide evenly by 48, but I can divide both of them by 24 and get 3 over 2. X to the 4 and x to the 3 just gives me an x, and y to the 10 and y to the 9 just gives me a y. The z to the 8s are actually going to cancel each other out. don't worry about the extensions for right now. If you really want to know about it, you can come and ask me. I'm definitely not going to ask you about this on a test or a quiz.